Hi. So, um, I want to talk about ANSI escape codes, right? Probably use it a lot. Probably use them a lot in making text like green or red in the terminal. But I think they are more powerful than that, right? And if you're wondering what I mean by like making text green or red, so you probably have done something like this, and you say yeah. So this makes it italic to 31. Ah, yeah, something like this, right? Let me just put a new line, something like this, right? So, yeah. So you've probably done something like this before in your app, maybe when you're printing logs to make it pretty in the terminal. Right? It's called the ANSI escape code, right? Or the ANSI escape sequences, and they are more powerful than that. They are more. They are not only used for printing colors. They can do a lot more than that. So I'm using this gist as a reference. It's a very good. It's what I use all the time when I need to reference something, right? So, and one of the things I like about it is it has almost everything you need. So yeah, so one of the good features or the cool features of ANSI escape code is how you have this command called clear that clears out the terminal. There is an ANSI escape code for it as well. So if we search for clearing, yeah, erase display. So we can erase the entire screen. So you can say 2J, and that clears it, right? So that's exactly one of the powerful things. Can also like move. You can move the cursor, right? So if I wanted to move the cursor down a bit, I can say 5B, right? And it takes me down by 5. If I want to go back up, I say 5A, and I'm up, right? So it's cool, like very cool. If I go up twice again, boom. So many things. And how does how does the terminal understand this? Basically, the terminal emulator is the one that im implements all this, right? So if your terminal emulator does not support ANSI escape codes, probably won't none of this would work, right? But most terminal emulators support it. If your terminal emulator doesn't support it, probably living in the 50s. Um, yeah, so I don't know the history much about how ANSI escape codes came to be and how it came to be the standard. If you have a podcast or a document about the history of it, I'm very much interested. I'm a sucker for tech history, right? Like, so I will appreciate that. So now that you see we can move cursors. We can also hide the cursor as well. Um there is this command, there is this escape code. Say so now my cursor is no longer visible, right? So I can also reveal it back with the H, and now it's visible. So and many more. So now that we know this, what I have in mind is how about we create a program where more like a terminal game, but it's going to be very very shit or very bad. But yeah, let me just like create a file and like um yeah, okay. So yeah, um I want to create a program that's going to clear the terminal screen and move the cursor around, right? Um, so let me see. Let's just try to do something basic for now. Let's say, so let's just print one. So let's print the one for clearing the screen, right? To J. And let's display, the cursor should be displayed. So let's just try moving the cursor down by 10 and move it up by 4. And let's put like a sleep here. Sleep for 3 seconds so we can see it happen, right? And let's do this for 2 times. Let's do it 5 times, right? So yeah, so let's try this out. And if I do, yeah. So yeah, it clears the screen, it goes down, but it's not going up, right? Which, yeah, it keeps going down. Yeah, so now it's over, but now our terminal is messed up, right? But yeah, let me look for the sequence for going up. Yeah, it should go up, but let me switch it to 10A. Ah, it's actually going up, but I'm seeing it very slowly. It's like it's happening too fast. Right. Let's make this. Let's just make it 1 second each, right? Yep. Yeah, so now we can see it's going up and down, right? Cool. Cool, right? So, but now whenever we run the command, we have a messed up terminal after, right? And there is also an ANSI escape code to like store the terminal state before you start anything, right? And then you would restore it when you are done, right? So there is like a save. There should be a save command. Yeah. So yeah, probably this guy. So if I do, let's try it out here first before we do it in code, right? So I've saved. Ah, no. Let me just do this and save it. Cool. So if I run the code and it destroys the terminal, and I'll try to restore it after, right? And see if it works. Okay, so let's do it again. But this time instead of ish, it's going to be L, right? So yeah, so like it brings back. Does it do? Yeah, it actually restores it. It goes back to when I wrote the print for 7H. You see, I can't see the L in the history, right? It tries, but I'm not sure if it's exactly what we want. But yeah, that's just one thing. But let me just add it in. Um, cool. So this is what something like Vim does. When they are done, they restore the screen. So because you notice we cleared the entire screen, but we were able to restore the screen back to show what was previously there, right? So now I said we wanted to build a game, so not just dance now. So what I want to do is I want a game where I can use the SJKL or the arrow keys to control the the display, the cursor basically. So the cursor can move around just like in film. If you know what I mean, right? So we can use the same up and down, right? That we were using. Yeah, so we can move up and down, left and right, A B C D. Okay, so what we can do is we can listen for key presses. So and to do that, probably just need to read from the standard input, right? So if I say so you can read 1 byte. But we're going to notice a problem. So we notice, so now I'm going to type in like ish, but it doesn't translate it immediately until I press enter, which is a problem, right? And the reason why this happens is because of the TTY driver. So the TTY driver is like in between the keyboard or and and the operating system, which then comes to the shell. I don't know how to explain it properly, but like I can give some good resources. So like for example, there is this good resources wizard designs. Yeah, so this particular one, the secret rules of the terminal, talks about the TTY driver a bit, which is cool. So you can learn something good from it. But yeah, so the TTY driver is in canonical mode. So basically it won't send any input to an app until you press the enter keyword. So but you can disable that. So so any app can tell the TTY driver that I don't want canonical mode. I want raw mode. I want to undo every input myself. I want to process every input myself. But the problem is, for example, Control C won't work anymore because the TTY driver was the one when it was in canonical mode. It was like, oh, you typed Control C, so that means you probably want to exit the program, right? And it sends a signal instead of an input. But if you when you enter raw mode, you won't be able to do that anymore. That's why you can't use Control C to quit Vim and so many things like that. So to set it to raw mode, I just set it to wide and set to raw, and I pass the file descriptor, which is just standard input, right? So now I've done this. it's going to work the way I want. So if I type in H, bam, it prints it out and it quits. Cool. So, but if I do a while loop, for example, and start listening to all the inputs, it's going to work, H, L. But if I do a Control C, I can't quit the program, right? So what do you do in this kind of case? We have to like implement quitting this program. So we also need to listen to like keys. So and I think Control C is going to translate as theory. It's going to translate as the ASCII 3 or the X 3. It's a control character basically. So we can listen to C and D, right? Control C and Control down. You can do break, and the program will end this way, right? So, but I need to quit the currently running one. So let me just do PS. Um. Okay. Yep. So it's this one. Q three. Cool. So now if I run the program again, if I do Control C, it quits. If I do it again, if I also do Control D, it quits as well. So cool. We're one step towards our goal. So we don't need to print it anymore. So we can do different cases, right? We can listen for ish, which means to go up, and we can print the escape sequence, right? So we need to go up by 1. So I will do it for J, which means going down, right? So if we try it out and I say J, yeah, it keeps going down. J, ah, it, and this should be K. S should be for left. All right. So for left is D and right is C. Yeah, so the left works, the right works, but now it's going diagonal, which is weird, and the up K is not working, which is weird as well. So, but I think we're getting the point. So that's my vision, right? So, and the point of this video is just to show you how cool ANSI code is and how much more it can do, right? Um, so yeah, let me clear the screen before I start. Before I start anything, right? And let me also move the cursor to 0. Cool. Okay, progress doesn't go up. I don't know why. Probably something I need to debug my spare time. So yeah, so this is cool. So another thing we can create is also like you know how this clear program works, and with saw printf, you can also like write your own version of the clear program and do it. So that's one of the many cool things you can do with ANSI escape codes. We can also like hide. We can hide the cursor. I think I showed that. Mm, yeah, it's cool. Yeah, many more things. Probably do like another video doing something more sophisticated um with it. But cheers. Let me know what you think. Do you think you can build something cool with using just ANSI codes? You can build a complete GUI and build something very, very cool. Sky is the limit. All right, cheers. Bye.